Today is our first look at solving trig equations, and the methods that we're going to use to solve these equations are just a mirror image of the methods that we used when we were solving for x. If we had an equation that had a common factor and we just had x in there, then we would factor out common factors whether they were numbers or whether they were letters. So in this case, we would factor out a 4 because both of these terms have a common factor of 4. We would also factor out an x because they both share an x. And we write that common factor out to the front, put the leftovers in parentheses right here, which means that we're dividing this by 4x, which leaves an x in the first term. If we divide the 16 by 4, that leaves us a 4. And we divide by the x, so there's nothing left in that term. So 4x times x gives me 4x squared, and 4x times 4 gives me 16x. And I haven't changed this problem at all, except to rearrange the way it looks. After we get those factors, we use the zero factor property, which says that if I have two or more things multiplied together and equal to 0, then either the first factor is equal to 0, or the other factor is equal to 0, or maybe they're both equal to 0. So in a case like this, I would set the first factor equal to 0, the second factor equal to 0, and get my solutions. So we'll see that pattern. Although it will have trig in it, we will see the same pattern in our trig equations. For the difference of squares, we have something like a squared minus b squared. Now the a and the b can be anything. They might be sine squared minus cosine squared. And when we get this factoring pattern, we know that the difference of squares is going to factor into conjugates, which is just a plus b times a minus b. We've seen this quite a bit, and hopefully you remember how to use it. If you get the sum of squares, then it does not factor at all. It may have a common factor, but other than that, the sum of squares is not going to factor. If we have the sum or the difference of cubes, we can factor it in this way. Again, I'm dealing with a and b, but a could be anything and b could be anything. If I have a cubed plus b cubed, then this is going to factor into a binomial and a trinomial. And the binomial is just going to be the cube root of each term. So cube root of a cubed is a, and the cube root of b cubed is b. And I want to keep the sign that I started with. So if it's plus here, it's going to be plus here. Now to build the trinomial, I'm going to depend on this binomial right here. I'm going to square the first term and get a squared. And to get the last term, I'm going to square the b and get b squared. This is always going to be a plus right here, because whether I'm squaring a positive or a negative, I'm going to get a positive b squared. Now to get the middle term of this trinomial, I want to multiply these two terms together, a times b, and then I want to change the sign. So if this is plus, this will be minus over here. Okay, that's a really good way to remember the sum or difference of cubes. If I have the difference of cubes instead of the sum, then I'm just going to have a minus between these two terms. And since I have a minus here, this is going to change to a plus on the middle term of the trinomial. A quadratic trinomial, the first thing that we're going to do after we take out a common factor, if there is one, is to factor this. So if we get something like this, then we would factor it into two binomials. So we'll be doing that with trig as well. And then if it won't factor, we want to use the quadratic formula. One thing that you have to remember is to never divide by a variable expression. If you divide by a variable expression, then you eliminate solutions that are valid for your equation, and you never notice that they're gone. They just don't show up. So never divide by a variable expression.